Hi students, and welcome to Preliminary Chemistry and the Chemical Earth video series. This time we're going to have a little bit of a look at some of the energy behind the changes, both physical and chemical changes that can occur in substances. So we want to have a little bit of a look at the fact that, first of all, energy is always involved in chemical change. Sometimes energy is taken in during the process or absorbed. Energy in is called an endothermic process. So whenever heat is taken in by the system, it's an endothermic process, and it can also be released. Energy out is an exothermic. So external, exterior, this means out. So if the energy comes out, then it's an exothermic process, and if the energy goes in, it's an endothermic process. This always happens. Sometimes, and in fact, usually both processes happen, and there's an excess of one or the other. So more is taken in than is released, or more is released than is taken in. We can tell this often in reactions just by the feel of a container. If it feels warm, then that means heat is being given out and that heat is being transferred to us. If it feels cool, then that means the energy has been taken in, and therefore energy will actually be transferring from our bodies into the container, which is why they feel cool. Energy can be involved with either decomposition or synthesis types of reactions. So let's just have a quick look at both of these processes. Decomposition is the breaking of one complex substance into simpler substances, such as its constituent elements. So you remember we looked at the decomposition of water as a liquid into its two component gases, hydrogen gas and oxygen gas. So this is a decomposition reaction. Now the pop test is actually the reverse of this. So when hydrogen gas is ignited in the presence of oxygen, it will form water. And this is a synthesis reaction because we're producing a more complex product from simpler, in this case, two elements. Now, the term complex here is really just to describe the relationship between compounds and elements, more complex compounds than simple compounds. It's not necessarily to suggest a polymer, for example. So synthesis is when we produce a complex compound from two or more simpler substances, and generally speaking, decomposition is the reverse. And we start with a complex one and we split it into simpler substances. And both of these require an input of energy. The reason that it does is because energy is required to separate the atoms or the particles in a chemical substance, which is based on the strength of attraction or bonding forces between them. Bonding forces can either be chemical or physical. We've looked at the moment at some of the chemical types of bonds that occur between different atoms. So this would be something like an ionic bond between oppositely charged ions, a covalent bond created by the sharing of electrons between two atoms, and also metallic, the sorts of bonds that occur between metal ions in a metallic substance. These are the three key chemical bonds that may or may not be broken when we are changing a substance. Now, if it's a metallic substance and we are just beating it into a different shape, then we are shifting some of these around. But if it is water, for example, that we are electrolyzing into hydrogen and oxygen, then some of these actual covalent bonds are being broken. Conversely, and we'll have a look at these in a little bit more detail later on, there are physical types of bonds that exist between the molecules. We call them intermolecular bonds. And there are actually three types of these as well, which we'll look at in a little bit more detail in future videos. But just to introduce them for you now, they are called hydrogen bonds. And they're the strongest type, and they occur between water molecules. Then there is one we call dipole-dipole interactions. And the third type are called dispersion forces. And we'll have a look at these in a little bit of detail in future videos. But at this stage, chemical bonds are always more, require more energy. They're stronger bonds than physical bonds. and so therefore when we make a chemical change, the energy demand is always much higher, energy higher, for the breaking of chemical bonds. The easiest way to look at this is to make a quick comparison between boiling and electrolysis. So in boiling, if we have a water molecule and then we have another water molecule, there is a bond between the two water molecules. This is an intermolecular bond, or a physical bond. And this physical bond is actually what's called a hydrogen bond. And I'll explain that in a little bit more detail later on. But when we are boiling, all we are doing is moving the molecules apart from one another. So in the liquid form, they're all sliding past one another as ice. They are held together rigidly in a crystal structure. But as a vapor or a gas, they are moving independently of one another. So all we need to do is remove any attraction between individual water molecules to move them apart. Electrolysis, on the other hand, is a chemical change, and it involves the actual breakdown of two water molecules where we actually break these bonds. So these bonds are the ones that are actually being broken this time. So anything that's going on between the molecules is one thing, but within the molecules, these bonds need to be broken, and they will then need to be reformed. So the two oxygens will come together as an oxygen atom, an O2, an oxygen molecule, sorry, an O2 made up of two atoms. And we will also have two hydrogens forming as well. So two H2 groups. So you can see here we have hydrogen-hydrogen bond. Here we have a double bond between two oxygens. And over here we have four bonds, which are all hydrogen-oxygen bonds. These bonds actually are breaking, and we have new bonds, new chemical bonds forming that shows you the difference between a physical change and a chemical change. Thanks for watching.